Now in the previous section, we have seen some of the basic IP sparse mode configuration with RPs. Now RP stands for rendezvous point, and RP is the root of the shade tree, and the RP is going to learn about the source and the receivers. Like we must configure an RP. RP is going to learn from where the source is sending a multicast traffic based on some PIM register messages, and the receivers, the routers, has to join to the RP by using PIM join messages. And then it's going to build some S, G entries from source to RP and receiver to RP, and then the receiver is going to build the shortest path to the source, and it's going to send out the prune messages to the RP to stop the multicast traffic. Now that is something we have seen much more in detail in the previous sections. Now what if there is no RP? Now if there is no RP, the source will not be able to register themselves, and there won't be any join messages process. So if you're using IPPIM sparse mode, then it's really mandatory you need to have an RP. Now in this section, we'll get into some of the different ways to configure the RP. Now there are two major different ways to configure the RP. Either we can go to each and every router, we can define an RP address. That's what we call as manual RP or static RP, or we can configure the routers to automatically learn about the RP informations. Now either by using a Cisco proprietary method, that is auto RP method, which is a legacy no more used, or we can go with the PIM standard method, that's what BSR method. So we'll get into more in detail on these things. Now right now we'll talk about static RP. Now static RP is possible to configure an RP for a multicast group address. Like normally what we need to do is here we need to configure the manual RP on each and every router, and we can have a common RP for all the routers. Now it is the more simplest way to define the RP in a small size networks, but this manual RP is not scalable for large and complex networks. Now the main reason is we need to go to each and every router, and we have to configure the RP by using this command, and this command has to be configured on each and every router. So and the one more condition is all the routers must have the same RP address. And if the manual configured RP, now all the routers must have the same RP address, and every router must use the same RP address. Now in case if there is any change in the RPs, it needs a reconfiguration on each and every router. And there is one more disadvantage with the static RP is there is no failover possible. Now failover means, let's say if I have configured an RP, maybe a router 3 as an RP. Now due to some reason this RP fails, there is no failover procedure to take over the function of the failed RP. So we need to ensure that RP must be available all the time in order for all the source and the receivers to register themselves with the RP. Now the configuration wise, it's going to be very simple and straightforward. We need to ensure that we are enabling sparse mode on all the routers, and all the interfaces must be enabled with multicast by using this IPPIM sparse mode commands. And we need to go to each and every router. In my scenario, we need to go to router 1, router 2, router 3, router 4, and router 5. On all the routers, we need to define the RP address. Now the RP address can be any interface, and we just need to ensure that that particular RP address must be reachable via IGP. So because of that, RP of check. Now this is something, the configuration of the static RP we have seen already in the previous lab in the IPPIM sparse mode. So we are not getting into the lab practical implementation of this. So probably in our next section videos, we'll be getting into some of the other methods of learning the RP, which are more commonly used. That is your auto RP and the BSR RP candidates.